All right, ladies and gentlemen, as we come back to talking about vectors, we're doing more component vectors, and I have two components here, a and b, 2 comma 3, negative 4 comma 5. I want to go ahead and add those two vectors. So simply put the addition sign between them, add the x components, add the y components, and we come up with negative 2 comma 8. Now it makes sense that if I have the vectors drawn here on the graph and we begin putting those two vectors together, we take the first one and we put it here, and then we take the second one, we put it here, connect them head to tail. That means we're going to have a vector that looks something like this, or back 1, 2, up 8. So it does make sense. Now let's go back to do IJ format here. 2 plus 3i plus negative 4i plus 5j. If we're doing this, it's really nothing more than combining like terms. So I have, again, negative 2i plus 8j. That is my unit vector form. Now, let me take a second and talk about unit vectors. Remember, if I had 2 times any vector, it was simply the same vector, but twice as long. In the same case here, I always stands for the vector 1 comma 0. So it's a vector that moves 1 unit in the x direction. J is always standing for the vector 0 comma 1, which means it has 1 unit moving in the y direction at all times. So if I take something like negative 2i plus 8j, that means I'm going to go 1, 2 units back in the x direction, and 8 units up in the y direction, which leads us in the same direction as here. 2 this way, 8 this way. So it's really nothing more than negative 2 times 1 in the x plus 8 times 1 in the y. Now, real quick refresher, we used x equals r cosine theta if we're given magnitude and direction. And that moves us to the x component. We used r sine theta to find the y component given magnitude and direction. Now what we need to do is we need to find something that moves us from component back to magnitude and direction. So if I was given, for example, 2 comma 3, what I would need to do is I would need to find the magnitude. Well, how do I find a magnitude? Well, that's a distance. So it's going to be some sort of distance formula. But we already know what the x distance is. It's 2. So we can take 2 squared. We already know what the y distance is. It's 3. So we can take 3 squared. Add the 2 up. So really, all we're doing is we're taking the change in x squared plus the change in y squared, which is the distance formula. In this case, 4 plus 9 is square root 12. Now, that's our magnitude. We need a direction. To find direction, all we really need to do is go right back up here and look at our picture for 2 comma 3. At 2 comma 3, you'll notice we have this triangle. And since x and y meet at a right angle, wouldn't it make sense that if I could just find that theta, I'd be all good? Well, how do I find theta given this side and this side? Opposite, adjacent, tangent. Tangent of theta equals y over x. So in our case, it's going to be tangent of theta equals 3 over 2. So all we have to do is the inverse tan of 3 over 2, and that's going to give us our angle. Again, by the magic of television, tangent inverse of 3 over 2 is 56 degrees. So what we have is we have a unit or a component vector of 2 comma 3, or a unit vector of 2i plus 3i. We can use a version of the distance formula, a squared plus b squared square root, to find magnitude. Tangent of theta is y over x, or a over b, depending if you're using IJ format, to come up with 56. So, this vector up here, vector A, is square root of 12, comma, 56 degrees. So, we can move from magnitude direction format to component, and from component back to magnitude direction. All very important pieces.